do here is to find Ix. And we're supposed to find Ix using source superposition, meaning you find the current with using just one source, and then you find the current just using another source, and you keep going through however many sources you have, and you find it, and then you add them all up, and that's what your total current is. So when you're doing this, when I'm redrawing this with just one source, whatever source I'm leaving in, I leave it as it is. But other sources, I want to get rid of them. And when I do that, current sources become open circuits, and voltage sources become short circuits. So I redraw my diagram so that I just have one source, and I do this to the other sources. So I'm going to start by finding just the voltage. I'm going to call it Ix prime, and that's going to be from just the voltage source, so from voltage source alone. And when I do that, I redraw it, turning the current source into an open circuit. Since that current source has become an open circuit, it really has just gone away. So it's just gone. And so I want to find Ix prime. When I first did this problem, I love to use nodal analysis, and so I did that. But then I realized that if I did nodal analysis, I have 3 nodes, so I'd have 3 equations. But if you do mesh, you only have 2 equations. So mesh is the better choice here, so we'll do mesh. And I'll call this one I1 and this one I2. And so going around that first loop, I have 2I1 plus 3I1 plus 2 times I1 minus I2 plus 48 equals 0. Going around the second loop, I'm going into the negative side of the voltage source, so that'll be minus 48 plus 2, and with the 2 ohm resistor here in the middle, plus 2 I2 minus I1 plus 6 I2 plus 4 I2 equals 0. And from the top one, I get 7I1 minus 2I2 equals negative 48. And on the bottom one, I get minus 2I1 to a 12 plus 12I2 equals positive 48. And when I did this before, I always weigh out the laziness, is it going to be harder for me to do this by hand or to actually reach over and pick up the calculator? And right now, at this time, I did it by hand, but now I don't want to do that now. So I'm going to use a calculator. So second system solve, it'll be a 2x2 equation, and we have 7 minus 2, negative 48, negative 2, plus 12, positive 48, solve. And I get I1 equals negative 6, and I2 equals 3. Now, if you notice, I2 is Ix prime. So Ix prime from voltage source alone, that is I2, which is 3 amps. So now I'm going to get Ix double prime from current source alone. So I'm going to redraw it and leaving the current source in, but turning the voltage source into a short circuit. So it will look like this. Okay, so the voltage source just turned into a short circuit, just straight wire. And now when I looked at this, I said, there'd be 3 meshes, and if I do nodal analysis, it'll be 3 nodes. So I'll do nodal analysis because that's my favorite. So V1, V2, V3. And remember with nodal analysis, you're adding up the currents coming out of the node. And a current coming out of the node is the voltage at the node minus the voltage at the other side of the resistor over the resistance. So it's so for V1, I'm going to do V1 minus the voltage at the other side over the resistance for all the paths. And if you actually already have a current, if the current is coming in, it's negative, and if it's going out, it's positive, because we're going to write them always with currents coming out of the node to be consistent. You don't have to be consistent, but if you're not consistent, you have to be really careful as labeling things. But if you always do it the same way, then you know that you're always coming out of the node. So my currents coming out of V1 are V1 minus 0 over 2, because I made the bottom ground, plus V1 minus V2 over 3, and then minus 4 equals 0. Now, some of you like to write it. I think the book does, or maybe that's the way you've done in class, just you go ahead and write it as equals 4, which is fine. Okay, and then V2. So I have V2 minus V1 over 3 plus V2 minus 0 over 2 plus V2 minus V3 over 6 equals 0. And for V3, I have 4 amps coming out, so that's a positive, plus V3 minus V2 over 6 plus V3 minus 0 over 4 equals 0. And I will multiply this top equation by 6 to get rid of the denominators. And when I do that, I get 3V1 plus 2V1 minus 2V2, and then it'd be minus 24 if I take it to the other side, equals 24. I'll multiply this equation also by 6 and I get 2v2 minus 2v1 plus 3v2 plus v2 minus v3 equals 0. And I'll multiply the bottom one by 12. I'll take the 12 times 4 to the other side as a negative 48. And then I have 2v3 minus 2v2 plus 3v3 equals negative 48. By the way, I can't do arithmetic. I make lots and lots and lots of mistakes. So if you ever see me mess something up, just say, wait a minute, isn't that supposed to be a 2? And I'll say, oh yeah, 1 plus 1 is 2. So just, yeah, you got to keep an eye. I cannot be trusted. Okay, so this first equation becomes 5v1 minus 2v2 plus 0v3 equals 24. The second equation is minus 2v1 plus 6v2 minus 1v3 equals 0. And the last equation, 0v1 minus 2v2 plus 5v3 equals negative 48. And I get V1 is 4.8. V2 is 0. And V3 is negative 9.6. But what I need is this current. So that current, which we're calling Ix double prime. So a current is always the beginning voltage minus the ending voltage over the resistance. So Ix double prime is V2 minus V3 over 6 ohms, which was 0 plus 9.6 over 6, which is 1.6 amps. So from the current source alone, we get 1.6 amps. And so now we've done all our sources. This one only has 2 sources. We did both of them. And so Ix will equal Ix prime plus Ix double prime, which is 3 plus 1.6, which is 4.6 amps. So any questions on that one? You don't have source? Yeah, she said you did. She told me in an email that superposition was definitely on the test. So, yeah. She said it goes through superposition. Oh, well, she may have changed it since she told me. So this was last week when I asked her, and she said up through superposition, but she may have not. Have I stopped recording? I have not.